In this video, I'm going to look at SQLAlchemy and Flask, and we're going to present the results of a query on a table on a web page. So we're going to have Flask handle the routing, and then SQLAlchemy handling the database, the creation, the loading up, the querying. And then again, with Flask and some Jinja, we are going to take that data, pass it over to a web page, and generate an HTML table from that. Okay, so let's get started. We'll start with the SQLAlchemy. We have just a very simple database with a single table, just the planets. So I have the data in a CSV over here called Kepler. I have 9 planets. I've included Pluto. There's no header here. I have a Python file just for the definition. And so I have sort of 3 versions of the engine. So here I'm working with SQLite, and I'm making a database where the file is called planet.db. I've commented out a line below where I am including the check same thread variable to be false. So that's going to be a little less secure, but it's going to be easier to work with. Sometimes I get multiple threads going and I get complaints. And that will sort of ease up on me and allow me to do that. And the second commented out version is just working with an in-memory database in case I don't want to keep the data around and just sort of playing around. Okay, so basic declarative base, column, integer, string, float. So I'm going to have an ID, which are integers, and have a primary key, which is true. The planets are going to have names, which is a string, and they'll have distances and periods, which are both floats. Okay, then I have a separate file here, which imports that file. So here's app_data_define as my_db. So I'm bringing that in. And I'm setting up a session with that engine. And then I am using my OS module to locate the file and read it. So sort of sticking with the sort of Flask file folder setup, I put it in static and then in a subfolder called data. And that's where my Kepler CSV is. And I could have had a module for reading CSV, but I just sort of did my own, looping through the files, making sure it's not a blank line, stripping it and splitting it on the comma. And the name, when I split things, are strings. So I had the name, the period I cast as a float, the distance I cast as a float, and I'm leaving the ID to be auto incremented. So it's going to start at 1 and go up through 9. Session.add is going to perform the SQL insert for me, and then a commit, so they actually get added to the database. So I never run the definition, but I do run the load. And there we go. I've run it, and now we should have a database. I can view. I have I think I have better Jinja installed. I have Python installed, and I must have the stop searching, and it'll tell me what I've installed, and the SQLite installed, so I can view the table I've made. I went through the gear, and gone to command palette and SQLite open database, and I'm choosing the planet database. And then go back to Explorer, and there is my planet database. There's my planet table within my planet database, and there are my planets. Okay. So I have data. I separate out of my query. I just have the most basic query in my query file of query the planet table and get me all the records and loop through them. So let's run that, and they're down, and that produces the results down in the terminal. Okay, and now over to the routes. So I'm now in Flask. So again, I'm importing my database. I'm importing some basic SQLAlchemy so I can set up a session and talk to the database. I'm bringing in some basic Flask so then I can have a route that's going to take that data then over and put it on a web page. Set up a session. Here from 14, I am querying the planet table in my database. So my DB is what I brought in the definition file as. And so then everything is going to be my_db dot, in this case, the class is planet. So I queried the planet table working through SQLAlchemy through the class, and results are all and then I'm printing them out. And then I am casting this. So I am taking, this is sort of a list comprehension. So I have my results. I'm sort of doing this quick list comprehension, one line loop, and I am making square bracket a list. And I am taking the items in my results list, and I am doing the dunder, the underscore dict, underscores dunder dict, and so I'm casting the records I got from the database as dictionaries and making that new list. So then I call that result underscore dict. So that's going to be useful. So now I know that's what I'm going to pass over to in Flask. That's what I'm going to pass over to the table. So now I understand the structure of what I'm passing over. I'm passing over a list of dictionaries. Okay, so some standard Flask stuff. I'm taking my default route and redirecting it to my planet table. And then here is my planet table. I'm sending over the data to an HTML file planet table, which we'll look at. I give it a title, planet table. I give it a header, planet table, and I send over that data I got from the database, from querying the database and casting it as a list of dictionaries. All right, so then here is planet table. It's extending simple layout. So simple layout has a place for a title, has a place for a header. So I sent the header and I sent over the title and the header, and then a content block. It also, the layout connects me to my style, and then back to planet. So then this, I'm extending simple layout. Here, the title is the title, the curly is indicating some piece of information that I'm using Jinja to insert. I have I'm in one of my extensions was better Jinja, and then with this HTML file here, I came over here down to this lower right and clicked and select the language mode to view it. And I chose, once I had better Jinja, I had Jinja HTML, and that gave me, it already understood it as HTML and was giving me some HTML styling, but this adds some Jinja styling to the HTML styling. Makes it a little easier to pick out things. So inserted the title, inserted the header, then we passed over. This is just a hard-coded 2 headers, H2s, and I'm setting up a table. I decided to have a thead and a tbody. You can get away without, if you just want a basic table that's showing up on a web page, you can get away without thead. When you want to have a fancier table that is like dynamic and does things, those often want thead and tbody. So I'm just sort of putting it in. So I have a table tag, and it must have a closing tag. There it is. I have a thead. This is for me, the head is going to be just a single row. So there's my single row. And then I have 4 headers. I'm going to pass over an ID, a name, a period, and a distance. So these were my main properties in my database. And then I'm moving over to the body. And so now I'm going to, I sent over planets. So let me go back to the, what do I want? The routing. And over here, within this file, I called it result dict, but then I called it planets. So by the time it gets over to the HTML, it's known as planets. And again, it is a list of dictionaries. So I am looping over using Jinja. I am looping over the list of dictionaries. So item is one dictionary. And we know that those dictionaries have the properties ID, name, period, and distance. And so I'm just making a row with these individual cells. So I had made the header rows above and just sort of stick to the same arrangement, the same order, ID, name, period, distance, ID, name, period, distance. Here I'm just sort of, I don't know, showing off. Then I can do, I have 2 notations to access a part of a dictionary. I can use a sort of a dot notation, and I can use a square bracket notation. So that one sort of works out. One's the dot sort of reminds me of object, and the other one more of associative array, but both work. So occasionally, when you're reading something from a JSON file or something, I don't know that you can have it in a database, but occasionally the name gets a space or something weird in it, and then so it's nice to sometimes know both notations, because sometimes the one notation is easier to work with than the other. So that generates a table for me, and then I'm just going to generate another table. And I'm going to, instead of saying I know the properties, ID, name, etc., distance and period, I'm going to discover them. I'm going to just sort of ask it to loop through the key value pairs of the dictionary and just see what's there. Now, one thing that you find that is there is an extra field which belongs to SQLAlchemy. And it is, it's not, doesn't represent the data in the actual table, because we did not directly query the table. We worked through SQLAlchemy. And so it has some additional information that it uses. And so there's an extra sort of key value pair, and it has this key of _SA_instance_state. And I don't want that crazy stuff showing on my table. So I'm going to sort of discover what's there, but throw out this one thing I know that SQLAlchemy has that I don't want. So long as I know I'm using SQLAlchemy, I can know to throw this out without necessarily knowing what the other fields in the database and the data table are. Okay. So some headers of blah, 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 again, a table head. And then here is my row. And then up above, I sort of explicitly said, I know there's an ID and a name and a distance and a period, but here I am discovering them. So planets 0, that is my first item in my list, and it's a dictionary, and I can say what are the items in the dictionary, and that is going to give me key value pairs. And I can say I want the keys. What are the names of so the keys would be the names of the properties, and I'm putting them in THs and in in table headers. And I also have this if, again, if it's this weird instance thing, the SQLAlchemy extra piece, then I don't want to display it. So I have a Jinja if not equal to that. If it's not equal to that, show me. Otherwise, skip it. Okay, here's my tbody. Now I'm going to loop over all the planets. So up here it was just the 0th element. That's because I was working with the keys and I just wanted to know what the properties were. Now I have nested loop. So I have a loop over all the planet records. And then my inner loop getting again over the items and skipping over the weird SQLAlchemy instance state, but this time getting the values. So I'm going to have the two tables. They'll be mostly alike. One sort of I sort of purposely arranged, said I wanted IDs and names, and the other ones I'm more discovering what there is. Okay, so let's finally run this sucker. Okay, so here is the route. That's what I want to run. I spit out down here I'd spit out what I got from the query, and then what I got, and then I cast it as a list of dictionaries and I spit it out again. So that's all this stuff down here in the terminal, but let's find where are we at. Here is our URL. And here is my table I made. So this top one again was a straightforward. I said I had a header with ID, name, period, and distance. So that I must have some styling. And my thead styling is different than my td styling. So that's how I got these headers looking different. But there was my table. I must have given the cells a border. And then here was the second version. This is where the code sort of discovered the key values. So this first row up here, the header was spitting out the keys and then spitting out the values in a nested loop. And one thing that so up here I can control the order, and down here the order was just discovered. The fields were discovered and their order was discovered, and they seem to be maybe in some order based on their type, because we see here the distance and the period, they were floats, then the ID was an int, and then the name was strings. So I think partially this ordering has to do with type. Okay, that's what I wanted to show you using querying a database, a SQLAlchemy, making it, populating it, querying it, and then taking the results of a query and passing them using Flask over to a web page and just putting them in a basic HTML table. Thanks for your attention.